Hey guys, welcome to the notes for product and power properties. These are two exponent laws that we're going to learn and we're going to apply. So if you're just having trouble with this, these notes, please come in and see me because this is something that people do tend to struggle with. All right, so this is in Unit 1A, and our essential question is, how are patterns in mathematics useful? So we love patterns because it makes things easier. Once we recognize them, it's easier for us to use later on, right? So let's talk about what these patterns might mean. So let's start off really simple, back to like elementary school. So here I have 3 plus 3 plus 3 plus 3 plus 3 plus 3. All right, that's a lot, right? If every teacher made you write that much, like that's too much. So how many times do I have 3 here? Right, how many times? Well, I have it 6 times. Well, if I added these all up, I get 18. Is there an easier way for me to write this? Well, I have 3, and I have it 6 times, and if I have 3 6 times, I can multiply that. 3 times 6 is 18, or 3 times 6 is 18, right? So that's a shortcut way. It would be a pain in the butt, right, to write it out every single time. So, moving on, we have 5 times 5 times 5 times 5. Well, I know if I put that in the calculator, that's going to give me 625. Let me double check, actually. Right, so it's 625. Well, is there a shorter way to write this? Well, I have 5 times itself, 4 times. That's also the same thing as 5 to the 4th. That also equals 625, right? So we want these short ways to write them because it's a lot easier. We don't have to write it as many times. So let's keep going. I'm going to do some examples with you, and then we'll keep building and building until it gets a little bit more challenging. All right, so number 1. Let's begin. So let's make this a little bit harder, and move it up a notch, right? So we have 3 to the 7th times 3 to the 5th. Okay, 3 to the 7th. What does 3 to the 7th mean? That means I have 3 times itself 7 times. Let's write that out. 3 times 3 times 3 times 3 times 3 times 3 times 3. So that is 3 times itself 7 times, okay? Now I'm going to do it with the other one as well. So here I have 3 to the 5th power, so that's going to be, that's going to be 3 times itself 5 times. So I have 3 times 3 times 3 times 3 times 3. And I'll actually put the multiplication sign in the middle, the same as the green one up there. But the blue is what I have in blue, and the pink is what I have in pink. So I'm trying to color code for you so you can see pretty clearly. So I have all of these 3's all being multiplied together. How many 3's are being multiplied together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have it 12 times. So that means I have 3, how many times times itself? 12. 3 to the 12th. All right, is there an easier way to do this? Do we see a shortcut? Let's look back here. Do we see a shortcut? Well, the shortcut is to add the exponents. I can just use 7 plus 5, and that would give me 12. That's the product rule, right? You add the exponents to get the other one. So this only works if they're the same base. The base is like the big number. The base is the 3 here, okay? So it's the bigger number, and then there's the exponent, which is the smaller number. Let's go ahead and try another one that's a little built off of that one. So we'll try one very similar. So this one's for practice for you. So 5 to the 5th times 5 to the 4th. All right, let's try this. Okay, I'm going to go ahead and expand it. I'm going to do it the long way, and then I'll show you the short way. So I have 5 times itself over here, 5 times. Okay, and then I have the multiplication in the inside there. And then I have 5 times itself 4 times. Go ahead and highlight those so you can see that a little bit better where those came from. Okay, well here, what is that? Well, I have 5 times itself 5 times, 5 times itself 4 times, so I really have 5 times itself how many times? 9 times. All right, now remember, if we use the shortcut, we can just take 5 plus 4, and then we get 9. Okay, so that is the shortcut. You just add the exponents, and that only works if the bases are the same. Okay, so let's build on that. Let's go ahead and keep going. We're going to keep going where it's going to get a little tougher. So here I'm going to use variables. So I have x to the 7th times x to the 5th. All right, so this one's a little bit different. Actually, that's also similar to the previous one. Let's do x to the 3rd then. Okay, so if I have x to the 7th, that means I have x times itself 7 times. So I have x times x times x That's probably annoying if I keep saying it, so I'm going to go ahead and stop. I'm not going to say it out loud and too much. Okay, so I have 7 of those x's, and then I have that one there, and then I have x to the 3rd power. Ooh, that was ugly. X to the 3rd power, and that's going to be x times itself 3 times. So if you were to count up all of these x's, how many x's do I have in total? I have 10 x's, so I have x to the 10th power. Well, isn't the rule the same? Can't I just still add these together? Yeah, I can still add my exponents together. So that is the product rule. So this was the really simplified version. So instead of writing it out so many times, you can just add the exponents. Now, if it helps you, if you want to, you can expand it out, but sometimes it gets a little lengthy, and you'll remember that. You'll be like, oh, I forgot what the shortcut is. I better learn it, right? All right, so let's build on this. Let's make this a little bit more complicated. Let's do 3x to the 4th times 2x to the 2nd. Let's do that. So let's try this, right? So this is a little different. So here, what do I have up here? I have 3 times x to the 4th. That means I have 3 times x by itself 4 times. I'm going to go ahead and expand that. So I have all of this being multiplied together. So this is all multiplication. There's technically multiplication signs between the number and the variable. We just don't write them. And if you're wondering, the number in the front is called the coefficient. So if it's in front of a variable, the number is called a coefficient. So I went ahead and I expanded this first term out. And I'm going to go ahead and expand the second term over here. So I have 2x squared. And in the middle, I still have my multiplication sign. So I have 2, and then I have it times x squared. Well, x squared is x times itself 2 times, so I have that. And now I'm looking, well, I have all multiplication, and I know that I have some things that I can combine, right? I can combine this one, this one, this one, this one, this one, and this one, right? I have 4 x's over here, and I have 2 x's over there. Well, if I were multiplying all of this together, how many x's am I really multiplying? I really have 6 x's, so I'm going to go ahead and put x to the 6th power. So again, you're just adding up the amount you have, right? And that was the same rule that we could use earlier, and I'll go ahead and go back to that. And then you could have, oh, I should have put that in green because it's in green, x to the 6th. And then now I have 2 and 3 left, right? But it's still 3 times 2. So I could still multiply these, and I'd get 6. Okay? Now let's take a closer look at all of this. So, is there a shortcut that we could have to make life easier? Well, the same rule that I used earlier. I have x to the 4th times x to the 2nd. Well, I really have 4 x's and then I have 2 x's. So I really have 6 x's being multiplied. So I can just add the exponent. And then here I have 3 times 2, and that would give me 6. So it's all multiplication there. Let's try one more before we move on to the next page here. Number 5. Okay, so let's have, I'm going to make this one up in my head. 3x to the 2nd, y to the 3rd, we're adding another variable there, times x to the 3rd, y to the 2nd, y to the 4th. Let's change that up a bit. Okay, so now I have these, and again, you can expand it, but let's look at it. Well, I have some bases that are the same, right? I have base here, I have an x squared, and I have also another base x over here. I have x squared, and I have x to the 3rd. So how many x's are really being multiplied together? And you might be saying 2, but remember, this is technically x times x, and this is x times x times x. So how many x's are really there? We have 2 over on the left, and we have 3 on the right. So really, we have 5. So we have x to the 5th power. Okay, let's move on. Do we have another thing that has the same base? Well, I know my y's have the same base, and their exponents are 3 and 4. Again, remember, this is y times y times y times y. Oh, just 3 y's. And this is y times y times y times y. So I actually have 3 on the left, 4 on the right. So how many do I have in total? Oops, I actually have 7 in total. So I have 3 and 4, which makes 7. And you're like, well, what do I do with that 3? Well, there's technically an imaginary 1 here, right? So I do have 3 times 1, so 3 times 1 is still just 3. So I'm going to go ahead and box that as my answer, but that is it for that one. All right, so that was product rule. So now we're going to add in something new. We're going to do the power rule. Now the power rule is a little bit different. I'm going to go ahead and start at the top of the page here. Power rule is a little different, but not too different. So let's start off pretty easy. We're going to start off with regular numbers. So I have 2 to the 3rd to the power of 4. All right, let's talk about what this means. I want you to think of the parentheses as a house, okay? Inside my house, I have 2 to the 3rd. What does 2 to the 3rd mean? Well, 2 to the 3rd means that I have 2 times itself 3 times. Let's go ahead and write that. I have 2 times itself 3 times. And then I still have everything else, right? All I've done is expanded the 2 to the 3rd, and I wrote it 3 times. Well, what does this 4 mean? This 4 means that I have 2 times 2 times 2, 4 times. So I have to duplicate this house. I have this house 4 different times. So I have 2 times 2 times 2, times 2 times 2 times 2, times 2 times 2 times 2, times 2 times 2 times 2. Oh, you say that enough, it gets a little silly. You sound a little silly. So I have it 4 times. And you're like, I don't see it. This is 1, 2, 3, 4. So this 4 is giving it to me 4 times. I need it 4 different times. All right, now let's condense this, right? How many 2's are being multiplied together? 12 of them are being multiplied together. So what do I really have here? I really have 2 to the 12th power. All right, now if we look back at the front, if we look back at the beginning, whoops, 2 to the 12th power. And actually, I'm going to change this color because I don't want it to be the same as the other one. Change that to green. Okay. What could the shortcut have been? What could I have done to get that 12 in the exponent? Well, I could have multiplied, right? I could have multiplied my 3 times 4. I multiply the exponents, and it gives me 12. Think about how the 4 and the 3 are exponents. They're like up there. They're like superpowers, right? So if they're superpowers, you think about multiplication and addition, which one has more power? Multiplication has more power. So if you see an exponent up there with another exponent, that's like super. So it's like you're going to multiply. You're going to do something extra, not just add. All right, so we're going to do one more example. I'm going to do it on the side over here so that I can save some room. I don't know how much room I'll need, so I'm going to save some room. Okay, so let's do another one with the numbers. So we have 5 cubed to the power of 5. Let's try this. 5 cubed. So let's use our rule. Let's use our rule, and then we'll double check by writing everything out. So our power rule was to multiply the exponents. So if you want to, you can write multiply next to these. So if you see parentheses, you multiply. And if you don't see parentheses and there's the same base, you add. So we have 5 to the 3rd to the 5th power. Well, here I said multiply, right? So I have 5 to the 15th. This would be the answer. So let's check it. 5 to the 3rd, what does that mean? That means I have 5 times itself 3 times. So let me go ahead and write that 3 times. And then I still have the 5 on the outside. Well, what does that mean? It means I have to write that 5 times. So let's go. All right. So I have the houses. I have 1 house, 2 houses, 3 houses, 4 houses, and 5 houses. So I needed that 5 times because it told me to do it 5 times up there. Now, what does that all equal? Well, Well, I have 5 how many times? If you count them all up, I have 5 15 times. So the shortcut does work. All right, so let's go ahead and try that with a variable. Let's do x to the 6th to the power of 2. So let's try this. So x to the 6th is technically x times x times x. Okay, I have 6 of those. And then it says I have 2 of them. So I'm going to have to go ahead, I have 2 of these. So I have to go ahead and say that I have these twice. So I'm going to go ahead and write 12 more, or 6 more. Right? So I have 1 house here and 1 house here. Because remember, what's inside your house is in the parentheses. So I have x to the 6, and I have x to the 6 on this side. I have 2 of them. So how many x's do I have in total? I still have 12, right? Well, I could do the shortcut. I could do 6 times 2, and that would be x to the 12th. All right, let's try another example. Let's get a little bit more complicated. Let's put 3w to the 4th cubed. All right, so what I've added here now is I've added in a variable and a coefficient. So I've added two things here. Let's expand this out. Let's talk about what this means. So I have 3 times w to the 4th. So let's go ahead and write that out. That 3 times w to the 4th, well, what does w to the 4th mean? That means I have w times itself 4 times. So I'm going to go ahead and write 4 w's. Okay, and then it also says I have it to the power, to the 3rd power. So I'll go ahead and show you that I took this and I expanded it out. And now it's saying that I have this many houses. I have 3 houses, so I need to have 3 of these. So I'm going to go ahead and multiply some more here. So I have 3w4 3 times. So I'm going to go ahead and do that. I have 3 of those. Now let's talk about all that I have here. How many 3's are being multiplied together? Well, I have 1, 2, 3. I have 3 3's being multiplied together, so how would I write that? That'd be 3 to the 3rd. Okay? Now, how many w's am I having multiplied together? Well, I have 4 over here, I have 4 here, and I have 4 here. So how many w's are being multiplied all together? I have 12, if we count them all. Okay, so that would be my answer here. And now I want you to look. Was there a simpler way we could have done this? Well, again, like earlier, I could have multiplied these exponents and I got the 12, right? 4 times 3 is 12. Well, where'd this 3 come from? Well, this 3 came from just putting it on top, right? I just distributed, kind of put it up there. I raised it to that power, so I just did 3 to the 3rd. So let's try an example very similar to this one, number 10. So if I have 5w squared, let's not do w, let's do something else. 5x squared to the 7th. So let's try this trick here real quick, right? So we learned earlier if we have parentheses and another exponent on the outside, remember it's super, so we're going to multiply. We're going to do 2 times 7. Oops, my Apple Pen is getting low. So we do 7. I'm going to kind of just show you that. I'm going to do 2 times 7. So that would be x to the what power? 14. And then we do the same thing with the exponent with the 5. So I have 5 raised to the 7th power. All right, so that's kind of what that one means. So instead of having to do all of the expanding, all of the writing out, I'm just going to use my tricks. All right, number 11. Let's add in some stuff. So let's do 3xy to the 3rd to the 4th. So let's try this one. With this example, we're going to do the same thing. We're going to use that shortcut we just learned. So we see there's an exponent on the outside, which means it's super, so we're going to multiply. So I'm going to multiply this in. I'm going to have y to the 12th. I'm going to multiply this one in. Well, you're like, well, there's no exponent on the x. Well, there's still one x there. You just don't really write the 1, right? We don't write the 1. And it's not 0 because if there were 0, then there wouldn't be any x's at all. So x would be to the power of 4 because it's technically 1 times 4. And then lastly, we have 3 here, so this would be 3 raised to the power of 4. All right. Sorry, I'm fixing that box from earlier. Okay, now let's go ahead and add in a little bit more information. So we're building, right? So I started us off really, really easy, right? We started with addition, went up, went up, went up. So it does get a little bit more complicated, but that's what we're expecting, right? Like we need to build up to the level that we need to be at, but we need to practice. So let's do something like this. V to the 5th to the 3rd times x to the 5th. So let's try this one. And you're like, whoa, I don't know. That's okay. Do the same thing we did earlier, right? We see a parentheses, we say super, so like, okay, multiplication. This is like a super, remember? It's up there. So 3 times 5. So it'll be v to the 15. Over here we have x, and we have x, and we have a 2, so 2 times 3 would be 6. So our exponents are going to multiply. On this next one, we just have 5 raised to the power of 3. And then I'm going to go ahead and copy down what I had earlier over here, because I haven't messed with it yet. Now that I'm looking at all of my stuff, I know that I can only have one of each variable. So are there any variables or any bases that I see that are the same that I could combine technically? Yeah, I could combine this one and this one. So how many x's are there technically? I have 6 over here, right? This is technically this, right? And this one is x to the power of 5, so I have that 5 times, right? So that means I have x to the 11th. I'll go ahead and copy everything else down. All right. Actually, I'm going to make that a different color. I like just making things different colors. Okay. So that's that one. And then we'll go ahead and do a couple more, and then we'll be done with our notes here. So let's go ahead and do another one. We'll do, let's do one without any numbers on the inside. So we have m squared n cubed and a z times m to the 4th and n squared. All right, so let's do this one. And then I'll go ahead and just add a squared out there. Why not, right? All right, so before you're overwhelmed with the amount of letters that they are here, amount of variables that we have, just pretend that we're just looking in the house. Let's look inside the house. So pretend like this isn't here. Okay, so we just look in the house for now. Do I see anything that has the same base? Yeah. I see that there's 2 m's here. So this is all multiplication. I have m squared, and then I have m to the 4th. Remember, m squared means m times itself twice, and this one is it times itself 4 times. So how many m's are really here? I really have 2 over here and 4 over here. So I actually have m times itself 6 times. And I'll go ahead and highlight those for you so you kind of see that. Okay, do I have any other like bases? Well, I know that the n's here are the same, so they're the same base. I have a 3 and a 2. I have 3 on the right side, 2 on the left side. If I multiply all those together, I technically have 5 n's multiplied together. And then I notice that my z doesn't have anything to go with, so I'm just going to go ahead and copy it down as is. There's nothing else to do. There's not really anything there. So now I've simplified the inside. Now I just have 3 variables, so it made my life a lot easier. Okay, now I'm going to bring the house back. So I'm going to go ahead and bring the house back with the square on the outside. Well, now this is just something like we did earlier. We're just going to distribute now. So if I have z to the power of 2, remember there's technically a 1 here. There is 1 z in there, so I have z squared. And then here I have n to the 5th to the 2nd power, right? We're doing super, so we're going to multiply. So this is n times itself 10 times. And then I'm going to multiply my exponents here as well, and I have m to the 12th. So remember, we multiply there. All right, hopefully we're feeling a lot better. And I just want to bring you back to one of the first problems we did. So with number 1 and number 2, I'll go ahead and add in a bonus here. So bonus 1. Okay. If I had 4 times 4 to the 3rd times 4 to the 2nd, right? How many 4's do I have here? Well, here I have 1, I have 3 here, and then I have 4 here, right? So I have 1, and then I have 3, and then I have 2. So how many 4's do I have in total? I have 7. No, I have 6. Oh, whoops, that was a big 6. 4 to the power of 6. So you do it the same way. So it doesn't matter how many things you have or how many you have of each, you still treat it the same way. All right, we're going to do one more example and then we will be done. All right, so let's do it. Let me look in the homework actually to see what I could pull that might be similar, something that we might not have seen before. Oh, let's do one of these. Okay, let's do 3x squared times 4, in parentheses, x cubed y to the 5th to the power of 3. Okay, a little bit different on this one, huh? All right, so this one does require us to use the product and power rule. Okay, I'm going to look at just the parentheses part. So see if I can simplify anything in here. Well, inside I don't have anything that has the same base, so I can't really do anything to it. So, oops, sorry. So I'm going to go ahead and just do my power rule, which is I see an exponent on the outside of my parentheses. It's like a super, which means I multiply. Remember, multiplication is more powerful than addition, so you do your super. So I have y, and then I have 5 times 3, which is 15. And then I have x to the power of 3 to the power of 3, which is going to be x to the 9th, right? We multiply those still. And then I have a 4. And this 4 is going to be raised to the power of 3. Not times 3, raised to the power of 3. So 4 times 4 times 4. So it is different than multiplying it by 3. And then I'm going to copy down the rest over here. So now I have this, and I want to look. Well, what things do I have in common? Well, the things I have in common, I do have some x's that are the same. I have the same base here. So I'm going to go ahead and talk about that. Oops. Oh, my Notability just like froze. So let me go back to my Notability. Okay. So my bases are the same. So I have 2 and then I have 9. Okay. And you know what? I'm going to go ahead and change this because I don't like it. So let's do a 4 in the front. So I didn't really change anything. Nothing changed, right? Because we never really even messed with that side. So I just changed the first number to a 4. Because I never messed, right? So hopefully that isn't confusing. I just wanted to change it because I wanted to show you something different. So I have x's with the same, I have x's, right? So they're the same base. And how many x's do I have? Remember, there's technically 2 here and there's 9 here. So I have actually 11 x's being multiplied together. And then I'm going to copy everything else down. So I've combined those. Also, I see that I have common bases of 4. My 4s are common bases. So I have a 4 here and I have 4 cubed here. So how many 4s are really being multiplied together? I have 1 over there and I have 3 over there. I really have 4 times itself 4 times, right? Because I have 4 here and then I have 4 times 4 times 4. So I really have 4 of them. And then lastly, I'll go ahead and copy these down. Right, so I don't have any bases that I can combine, so this is the simplest I can get. All right, so that is it for our product and power properties. So if you have any questions, please feel free to come in and ask. We did escalate the level of the difficulty, right? Like we ended here and we started here. So if you have any questions, please feel free to come in and ask.